So this is the second application. Like last time we saw how to apply logarithmic function in to measure the loudness. Remember we did this? How to measure the loudness or how to check which one is more intense or how many times more the one of the loud compared to the another one. So that we have seen. This is the earthquake which I did in my other class, okay, which I'm gonna post it. You can check that separately. But today my focus is on this pH. Okay. So now pH of a solution is, so the formula is given as pH is my negative. So can you copy this last formula again, even though if you copied in the notebook? Write it one more time. The last one only. So pH equals negative. Now everybody question why the heck this negative, where does this negative come from, right? So always that question. And they use the logarithm, log. And then when there is no log, basically it means log. If you see the calculator, when you write log and if there is no number, basically it means that's all that means. So the base used is the 10. Is that okay? So negative minus log hydrogen. Before we let me show one more thing before I use the formula and we do the problems. Okay, before, so thumbs up who copied this whole thing. 1, 2, 3. Did you not copy? Okay. Can I see thumbs up? Everybody must copy this. 1, 2, 3, 4, 5, 6, 7. This side. No. Can I see your book, notebook? Some of you are not writing down. Please, let's start. Let's be serious. Let's do some work. I'm not asking rocket science. Thank you so much for everybody who did this. Now, point is, before I straight away go those, many of you must be wondering where does this number come from? 4.5 or maybe 5.6, 5.6. All these numbers, where does this thing came from? And what is this? Can you see this? So pH is 0, 1, 2, 3, 4, 5, 6. This is called this is the scale used for pH, right? So it increases from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 14. The higher the pH, the less is the acidic, and the lower the pH is the acid. So the lower the pH you see, it's more acidic kind of thing. So that's one observation, but some of you may be questioning where did this came from, like? So that's what my point was. Let's see why. And don't copy anything, just watch this. What do you think you see here? Take 1 minute. Watch this, okay? then the next column, and the next column. I see 3 laptops open. Can you close the laptops, please? You have so much time I gave to do at home, not now. I know many of you want to finish the packet, get your 80 points, but not now, please. So think over it. Did I start recording that? It's recording. Okay, 1 minute up. Everybody's eyes here. Look, today is Friday, right? Friday? The end. We go home. But when you walk out of that door there, the question is, what the heck we learn in the class? I want you to take it away. Take away, okay, I think Mr. Ribella was trying to show something about logarithm. And what it's got to do with our real life? Look at this. So all this substance, we call them. In chemistry, they are called substances. But in our life, we don't call substance. We just say, hey, that's baking soda, blood, milk, we drink milk, we eat banana. Of course, no, not everybody has banana, but I eat every day 1 banana after lunch, 11:30. Then tomato, we cook, right? Or even we eat while the lunch and dinner, we always have tomato, apple and orange juice. And then the lemon is what you put for the food, right? Salad and all they use, vinegar, those things. So my question to you, as you watch this, some stupid numbers are given. What the hell is this? I don't know. Like these are all the chemistry and those those do research on, checking on. Like every substance has got carbon, hydrogen, all those nitrogen and all that crap which you like. I used to hate chemistry, but in the beginning. But actually, it's all about what we see in our life. Everything is made up of elements. The periodic table that is the metals, non-metals, and all the nitrogen, ammonium, copper. We know metals, gold, silver, aluminum, iron, and all that. But everything is mixed and something is formed, right? So in this case, this substance that we have right now here is. You start with the bottom by lemon, the yellow lemon that is in Food City, Walmart, Safeway, and everywhere. Price. Just put the green one and the lime, we call lime is the green, or lemon is the yellow one, the big one. I like to put the yellow one on my. I cut onion, I put little of carrot and and little of squash. And I just cut all those pieces, make a lot of. Lettuce, spinach, just mix it and eat. No meat is required, just that's it. It's good for health. Have as much as leafy vegetables, green, avocados, green vegetables, right? Asparagus. More vegetable, you become strong. Not strong, healthy. Become healthy, right? Nobody's saying yes. Agree? Right, no? Life is all about being healthy. Everything becomes so, what's the point of having thousands of billions of dollars if our health is not good? Right? We need to have a good, balanced diet. Watch this. Okay, so what I'm trying to say, lemon 0.01. What the heck is 0.01 means? What does 0.01 actually number means? In scientific form, maybe, can you write in the exponent form? Somebody tell me, what is that? What is this? Please, you don't write anything. I'm just trying to present it. Would you like to share? What is this? In how do I write something like 10 using 10? 10 raised to, what is it? Anybody? Thumbs up? Say it again. Little loud? Negative? Okay, so you said 10 to the power. What should I put here? Very good. Now it's okay. Some of you got confused. No, developer, I don't know. That's okay. But the thing is, remember when you write 0.01, if I multiply, what's this? 100 up and 100 down. What it means is I don't want decimal, right? No more decimal. What does this is this become 1 over 100. Can you see that? 100th. So the place value here is, you see this 1 is at the 100th place. So there is a 0.01. If I had a 0 here, 0.01, what does this mean basically mean? 1/10, right? That's one. So this is like 1/10. Agree? Nobody likes decimal, I tell you. So 1/10, so it's like you're adding 0.1, 0.1, 0.1, 0.1, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. How much? What do you get? Do you get 1? Yes or no? Yes or no? So if you add 0.1, 10 of them, you get the final answer is 1, right? So each one is 1/10. So it's like, okay, this means it is 1 over 10, 1 over 10, 1 over 10, 1 over 10, 1 over 10. So everything adds up, 10 of them. So the answer is, so 0.1 basically is 1/10. I mean this one. So if it is 0.01 is 100th, TH, 100th. And we get confused with this kind of thing. Okay, what about this? What should I write here? Can we write faster now? So this answer I got 10 raised to minus. What about this one? Somebody else other than, what's your name? Can somebody else tell us? What should I write here? Come on, try this.
10.
10 raised to what?
Minus 3.
Negative 3. Perfect. So there's something process going in your mind, right? And you're saying, oh, the Rebella is saying after decimal 1, 2. So you put minus 2, right? Now you see 1, 2, 3, correct? That's all it is, so simple. So what about the next one? Very good. 10 to the power 1, 2, 3, 4. So you put. It's like getting away with the decimal, you put a minus up there. That's all it means. And now you know the trick, right? It just goes like that. But what is important is, lemon juice, lemon is and I forgot about what are these numbers basically? Hydrogen ions. So, there's hydrogen ion H raised to the plus. So in chemistry or science, they have called some hydrogen ions. Like let's say the lemon thing, it has how many hydrogen ions in 1 mole hydrogen of ion concentration. It's like moles per liter. They measure moles in a liter. So confusion is what is 1 liter, right? 1 liter is 3.78 gallons. So I made a mistake. 1 gallon is 3.78 liters. Is that okay? Almost like 4 gallons. I'll just put it 4 gallons, a quarter of it. So if I want to know 1 liter, if this is the whole gallon, I can split into this much of maybe lemon. So it's saying it has 0.10th of a hundredth of a mole in a 1 liter kind of. A gallon has got almost like 4 liters. So we say, okay, in that liter, how many moles of hydrogen ions are there? Got it? So so here it is higher the hydrogen ions. You see this? So here there are more 10 raised to minus 2. This is bigger than this. Can you get out of my class? Get out of my class. Just get up, take your bag and get lost from here. You don't want to learn nothing, just get up.
No, I'm actually learning.
No, just go. Take your stuff, get lost from here. Just stand outside or sit down outside anywhere there.
Oh, you want?
Yeah, sit outside. Just don't bother the class. You don't want to learn anything is okay for me, but when you disturb everyone, that's the problem. Sit down outside there. Okay, so what I wanted to show you, look at this, so beautiful things happening is 10 raised to minus 2. So what's happening is when you go from top down, every time you multiply by 10. See this? So you multiply by 10, you multiply by 10. So 10 is such an important number. Everything is 10 times the previous. So the lemon juice, lemon here, which you see is 10 times what you had for apple. You see what's happening? 10. So it is tomato is, the apple is 10 times this tomato. The tomato is 10 times the banana, or 10 times the milk. This is 10 times the blood. So the milk that you drink, that one has hydrogen ions concentration, which is 10 times what your blood has. Correct? This is what I'm talking about. Get that, it's so nice to know this algorithm. I know it is hard because the numbers are confusing. These numbers are stupid. They are not nice numbers. They are like 0.000. What the heck, where these numbers come? I don't know. But the scientists, they who do the research, they know, right? Better. So anyway, what I'm trying to say, and my point is, okay, there is 1, 2, 3, 4, 5. Let's do it quickly. 10 raised to minus 5. 1, 2, 3, 4, 5, 6. So you 10 raised to minus 6. Read down and bring, right? So you write in the exponent form. This is 10 raised to minus 7. This is 1, 2, 3, 4, 5, 6, 7, 8. So 10 raised to minus 8. It's like you're moving the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 raised to minus 9. Agree? Yes or no? Are you with me? I know I'm talking. I'm just talking. And this one is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 raised to minus 10. Agree? And look at this beautiful thing happening. Is there a connection between? Is there a connection between this number? Is there a connection between this number and those numbers? What do you see? Same? He's saying same. Anybody disagree with him or yes? Is it same? My question is, this exponent that are there, what is that got to do with the right side number? Are they exactly the same? What's the difference? What's the change? What's the change? So you see this minus 10 and that also is minus 10? No. What is that? This is plus, right? Is it not plus 10? Plus, right? So all these numbers are plus. Agree? So whenever this number, all you do is just write the opposite of that. So the mathematician, what they said, okay, how do we measure this? If you know this number, they put a minus sign. Do you see this minus sign? Yes or no? See how this minus came from? So they put, okay, this one is opposite. Let's make them opposite. So you put minus sign and logarithm. This is the base 10, and whatever the hydrogen ions. So this will be your 10 raised to whatever that number, minus 10, minus 9, minus, they will come right here. And that negative and negative becomes positive. The formulas are right here, look at it. If there is a minus sign, this minus sign is also 1 over x. And remember this was 1 over 100, this was 1 over 1000, this was 1 over 1000, 10,000 like that. So it's going to be something like this, 1 over x. And that's why they put a minus so that eventually the minus goes away. So I try to show this just to show where did this formula come from. Okay, it's because of negative and log, and this number is straight away this number, all this number. So you put this number right here and then you multiply like this. Do you get what I'm saying? You got lost, little lost. I know. Let's go to that one what I showed you. Watch this. Okay, and then I was saying this part, right? So all this is, they already gave us the different pH. The higher the pH, look at this, higher the pH is all this, they call it alkaline. Alkaline means very, very low acidity. So like bleach, what you are cleaning your thing, ammonia, then the milk of magnesia, baking soda, seawater. Look at the eggs, and the eggs is pH is 8. The pure water that you drink, the water that you drink is 7. Means it has hydrogen ions 10 raised to minus 7. 10 millionth hydrogen ion concentration. So main thing for me is, this is 10 raised to minus. Basically it means the hydrogen ions are 10 raised to minus 7. The 7 means it is 10 raised to minus 7, which is 0 point, and I have to put 6 zeros like this. Can you see that? So basically what that means is, this is ones, tens, 10, 100, 1000, 10,000, 100,000, 1,000. So this is like 10 millionth. So this is 10 millionth. 1 million is 6, right? So a lot of information about that. But then now, how do we use? The goal is now, okay, Deepala, what are you talking about? You spoke so much, then where do we use this? Can you just show us the problem? And that's what I want to show now. So last time we saw here it is. Can you copy this 4 question? Only this. So there are 4 questions and they give hydrogen ion concentration for ammonia, vinegar, lemon juice and oranges. The question is asked, find the pH. I'm going to do only one problem, the rest you do. Instead of 23, I'll call this as 1, 2, 3, 4. Let's call this as 1, 2, 3, and 4. So let's do the fourth problem together. The fourth question says orange juice. Everybody has orange juice. You see, if you go out, walk outside, the teacher always gives a lot of orange juice and apple juice. And the end of the day, I always see they all get over. It means students are having the juice, and it's so nice to see. So orange juice it's given to you H plus is 3.16 times 10 raised to minus 4 mole. So every liter there is so much of hydrogen ion concentration. So basically this bit means I can write 1, 6 and there is a 4, so I can move my decimal 4 places to the right. So 1, 2, 3 and 4 and 1. That's what actually that means. So if I have this number, this is called scientific notation, see. And I can expand and write like this also 0.00036. It's like 1, 2, 3, 4, 5, 6 kind of thing, right? So the question is, how do we figure out what is the if you see your notebook, you already know the answer, but we want to know using the formula. So H plus is given, the formula is pH is negative logarithm to the base H plus. You write this? Is that okay? So far so good? Nobody's saying yes. That's the formula. Now, and I try to even show you why the formula existed, because I showed it's always the opposite, so there's minus there. And one more thing, always remember, you have to know that log to the base b, if these two numbers are same, is always 1. Remember this. And then another thing is you should know also is log of b, and there is b raised to a exponent. That is same as this m is log bb, which is straight away m. So whenever these two things are same, these two numbers are same, this b and this b same, the answer is that same m. So this is special. We are still working on it. You're tired? It's tired, right?
Yeah.
We are just finishing and just get it, right? Now, what do we do now? Next is equals minus logarithm to the base 10. What do I replace this by? Somebody help me? What is h plus is? Can you see this? Right? Nobody's saying yes. So it is 3.16 times 10 raised to. Okay. Now you will say, Rebello, can't we just put this number and use the calculator? Yes, you can. You can directly do also. But I'm just trying to show how the process works. Now, if there are two logs multiplied, this is formula here. If there is if there are two logs are multiplied with m times n, you can separate this. It means, now I could have shown you directly here, just do 4 minus log of this number. That's how it is. So directly It's like you could work this out and say whatever this number, you just write 1 with the opposite and subtract log of this 3.16 and you can do the answer. That's it, you're done. But the question is, where the hell we got this from? So that's the point I'm making. Minus logarithm to the base. So I'm going to separate this. So I split this 2 logs. Instead of 1 log, it's 2 logs. 3.16 plus logarithm of 10 raised to minus 4 to the base. So you kind of separate the minus. Is that okay, Anil? And then you use the distributive, the minus, this minus, it's like minus 1, right? So you multiply here and you also multiply here. Do you see that? So distribute the negative. So this thing will become minus logarithm of 3.16 and this negative will be, this minus will be right here. And then again, you see this thing, the formula, that m which you see over here, this m in this example is this minus 4. So directly this negative 4 gets multiplied right here also because of this formula. So anything, if the base is here and this is b raised to m, it is m times log of that. So this negative 4 gets multiplied negative 4 actually. Straight away, without even, because you're ending up getting log of b to the base b, which is 1, so directly. So this negative makes it positive and you get 4 minus logarithm 3.16 to the base 10. And this is what you're going to put on the calculator. Okay, so at this time, I know the calculators are right there. All you do is you can try it on the computer, put this and you're done. Dalsworth.com. Put this on the. I hope I made some understanding of what is pH. Did you get something? Thumbs up, who got it? Okay, some of you got confused. So we'll continue on Monday on this. Thank you so much. Work is in the black. There's a black tray there, you can